What is this multiple L section filter? So more number of L section filters to get effective filtering. So we are using more number of LC section filters. So you can see the circuit here. This is the one, followed with another inductor, followed by the load resistor RL. So this is L1, this is L2, and this is C1, and this is C2. So here, this is the rectified output. Rectified output. Next is the respective terms. We'll write it here. So here, this is I1, and this is I2, and across this one, this is VC1, and this is across this one, this is VC2. So I1 is there, I2 is there, VC1 is there, VC2 is there. We'll specify the respective nodes here. This is A1, this is B1, this is A2, and this is B2, and you write this to be A3, and this is to be B3. So you are using two sections here, LC sections. The first section and this is second section. You can write it as a double section LC filter, double section LC filter. And here you are getting plus and minus V0. Okay? Note cheskunnara?
Yes, sir.
So here the first point is, the reactance of inductor. Inductors are very large compared to the reactance of capacitors. The conditions for this multiple section filters, and the reactance of last capacitor. What is the last capacitor here? What is the last capacitor? That is C2. Is very small compared to RL. So these are the two conditions what we have to see. The reactance of inductance is very large compared to the reactance of the capacitor, and the reactance of the capacitance of the last capacitor is very small compared to the load resistor RL. Okay. Now we will go for the impedances between, how to take up the impedances between the respective nodes, between one is A3 and B3. One thing. Similarly, another is A2 and B2. Mood chain kadamma, A1 B1 and A2 B2 and A3 B3. So this is nothing but A3 B3 ki, this is expressed as XC3, and this is, sorry, XC2, XC2, another is XC1, and this is XL1, or you can say XL. Go back and see this one. This is XC2, XC1, and this is XL1. So A3 B3 maddalo, it is nothing but XC2, and A2 B2, this is XC1, and this is A1 B1 XL1. You are writing three different impedances from the given circuit. You note this, Sarah? Okay. Now we have to calculate the respective currents in the given circuit. So here ఒకటి I1 ఉంది, ఒకటి I2 ఉంది, voltages VC1 ఉంది, VC2 ఉంది, respective current and voltages we'll see. So for the first section we'll see. Now you take first one I1. I1, I say that this is IRMS dash of L1 C1 filter. I1 is expressed as in the mundo LC filter ku enta ma value, IRMS value. Just go back and tell the value to me. LC filter ku first section lo chesanu nenu. What is I1 calculation? IRMS value. IRMS of LC filter. IRMS is equal to
2 VDC by 3XL.
లేదు ఒకసారి ఇంకోసారి చూడమ్మా root 2 by 3 VDC by XL ఇది ఒకసారి చూడండి
Yes, sir.
ఏమ్మా అవునా
Yes, sir.
This becomes root 2 by 3 VDC and this is 1 by XL1 1 by XL1 ఎందుకంటే ఇక్కడ ఇండక్టర్ L1 తీసుకుంటున్నాం అంటే ఒకటి రెండోది L2 అంతే కదమ్మా పైన రెండు తీసుకుని L1 and L2 ఫస్ట్ సెక్షన్ చేస్తున్నాం this is okay so this is nothing but I1 this is nothing but I1 now you have to calculate voltage across C1 దగ్గర voltage ఎంత రాసాను అక్కడ what is that one VC1 అదే కదా రాసాను అక్కడ
Yes, sir.
That is nothing but current passing through the capacitor I1 into XC1. Okay. Current voltage across C1 is nothing but V is equal to I into XC, that is I1 into XC1. I1 value, this is root 2 by 3 VDC, that is XC1 by XL1. This is okay. Emma, is okay?
Sir.
Okay, sir.
Next we are going to go for I2. I2 ekkada pass avutundi? I2 is nothing but this one passing through the inductor L2. So I is nothing but, that is I2 is nothing but, you can take it as the voltage which is coming across after the first section, that is nothing but VC1 into 1 by XL2 flowing through the inductor, that is VC1 into VXL2. So you substitute the VC1 value again here in root 2 by 3, that is VDC XC1 by XL1 into XL2. This is I2. This is okay?
Yes, sir.
Okay. Next is again VRMS dash is nothing but, that is nothing but VC2. Voltage across C2, that is VC2. This is nothing but I2 into XC2. అవునా కదా ఏమ్మా I2 into XC2. ఏం చెప్పట్లేదు మీరు
root 2 by 3 VDC into
ఈ ఫార్ములా ఓకే కదా అది దాన్ని సబ్స్టిట్యూట్ చేద్దాం
Yes, sir.
ఇది ఓకే అంటే నెక్స్ట్ దానికి ఇద్దాం అది డైరెక్ట్ సబ్స్టిట్యూషనే root 2 by 3 VDC into XC1 XC2 by XL1 into XL2 అంతే కదా now here this is
Yes, sir.
V dash RMS మీకు చెప్తున్నాను this అంతా నాది now I am just putting this VRMS by VDC again what is this one what is this VRMS by VDC ripple so this becomes root 2 by 3 here this is XC1 into XC2 by XL1 into XL2 okay now say XC is nothing but XC1 into XC1 is equal to XC2. Similarly, XL is equal to XL1 is equal to XL2. So what is the expression becomes? Ripple becomes root 2 by 3 into XC by XL whole square. Antena? Emma?
Yes, sir.
Yes, sir.
Now n ఇది 2 stages ఎన్ని ఉన్నాయి అక్కడ డబుల్ స్టేజ్ కదా రాసింది నేను అక్కడ వాట్ ఈస్ దట్ ఐ హావ్ మెన్షన్ ఇన్ ద సర్క్యూట్ 2 L section filters ఇప్పుడు ఇఫ్ యు గో ఫర్ n LC sections formula becomes